Hey, this is Mr. Ward. I'm going to do a second shorter video on how to deal with slope. And I'm going to simply take you through 3 scenarios of finding slope. And we'll use the change in y over change in x equation. So slope is the change in y. So I write change as a triangle in y over change in x. And of course, we can do that mathematically by just saying y1 minus y2. There's no reason this doesn't say y2 minus y1. It's just I chose to put 1 first. You could do it y2 minus y1 over x2 minus x1, as long as you kept everything consistent. So I've got 1 to 2, 1 to 2. So I'm just going to treat each one of these as this will be 0.1, and this will be 0.2. And the first, I'll figure out that down here in a second. So let me go here, and we will work out the y1 minus y2. So y1 is 1 minus 27, so 1 minus 27 over the x1 minus x2, so it'll be 8 minus negative 3. And we can reduce, we can simplify things. So 1 minus 27 is negative 26, and 8 minus negative 3 is 11. And so we've got negative 26 over 11, and that is the slope. That means that between these points, if I have from 8, 1, and I've got negative 327 going between them, that's going to be a negative slope down 26 over 11, down 260 over 110. Any equivalent fraction for this will work, but down 26 over 11. We'll take care of this one now. Now here we've got a 0.1 and 0.2. I've arbitrarily declared that this is 0.1 and this is 0.2. So I will start by getting the change in y, 8 minus negative 2. So 0.1 has a y value of 8 minus negative 2 for the y value of 0.2. I'm going to divide that by negative 5 minus negative 3. So I go negative 5 from 0.1 for the x value minus negative 3 for the x value from the other one. And see, it tells us the answer is negative 5, but let's demonstrate that. 8 minus negative 2 is 10, and 5 minus negative 3 is going to be negative 2, and 10 over negative 2 is the same as 5 over negative 1, which is negative 5. By the way, if you were plotting things, it'll be useful to call that negative 5 over 1 because we go down 5 and over 1 between these 2 points. So down 5 over 1, down 5 over 1. For any pair of points on this, that's the relationship. All right, let's take a look at these next ones. So we'll call this 0.1 and this 0.2 once again. And the y value for this one is 21. The y value for that one is 11. So 21 minus negative 11 for the change in y, that's a 32, as you can see there. And then we get the change of x, 22 minus negative 8. And that's going to be 30. So we simplify that. 21 minus 11, negative 11 is going to be 32. And 22 minus negative 8 is going to be 30. And we can reduce that. 32 and 30 both share a factor of 2. So we'll make that 16. And that will become 15. And that's your slope. Rise of 16, run of 15. All right, now the final one here, it doesn't matter which one of these I pick, but these are points. I just need any 2 as long as I know this table is linear, which it is. And you can eyeball that it's linear because the dots form a straight line. So I'll pick, let's see, I'll pick this to be 0.1 and this one to be 0.2. And that was fairly arbitrary which one I picked, but I had to pick something. So there you go. So let's work it out. So the change in y from 0.1 to 0.2 is 24 minus 2. So that's going to end up being 22. And I'm going to divide that by the change in x, 7 minus 1. And that would be 6. So I can simplify the subtraction. 7 minus 1 is 6. 24 minus 2 is 22. I can reduce that further. Factor a 2 out of the top and bottom. That's 11 over 3. So I have a slope of 11 over 3 for these 3 points. So up 11 over 3, up 11 over 3 will work as a relationship, their rate of output change to input change.